Well, hello. Nice to see you, Greg. Haven't spoken to you for a couple of weeks since we last caught up. Thanks for taking the time out to do this with us. So obviously, I guess introductions would be a good place to start. I mean, I guess obviously, I assume people will realise I'm the CEO at Opteran, um, but I know we met when you were working at Amazon. But perhaps aside from that, you could perhaps tell us a little about who you are and how your journey in robotics started.
Sure, sure. So I'm Greg Longtine. I'm currently the founder of a new robotics company as of a month ago. But previous to that, I was the first product manager at a company called Kiva Systems, which was one of the first companies that ever applied robotics to the supply chain. Right? It was a way to automate a lot of fulfillment processes through a structured field that would actually take robots and bring inventory to people to do order fulfillment. And I worked there for 6 years. We grew the company up to allow for sales to well over a dozen, 15 different companies across the world. And then we got purchased 12 years ago by Amazon and became Amazon Robotics. So after that, I helped deploy the Kiva technology within Amazon and across our fulfillment center, which was quite successful. Uh, to the point where over 750,000 of our robots have been deployed worldwide through Amazon. And after that, we really wanted to expand the robotics concept across the entire supply chain of Amazon. So I kind of grew as my product manager role beyond the original just managing the Kiva technology to more of an R&D role to think about 5 years out how we can deploy Amazon robotics. So I helped create a robotic platform that was for mobility that was leveraged in our sort centers for sorting packages down to zip codes. We've deployed several thousand of those. I helped kick off some manipulation solutions. So Amazon has a couple of manipulation solutions that are public at the moment for manipulating boxes, particularly. So we've moved over 1 billion boxes. That was beginning at the initial conceptual stage of that. And then recently I've been working in the research and development lab about expanding robotics out into even into the delivery station and all the way out through the supply chain. So for the last 18 years, I've been figuring out ways to allow for robotics to optimize and enhance the entire supply chain of, first of all, just general customers through the Kiva world, and then now through the ever emerging enormous Amazon fulfillment center supply chain world. So that's it. I've been probably have more
That's
experience applying that than anyone else in the world at the moment, actually.
Yeah, I think you probably have. I mean, the scale of deployment at Amazon is just it's exceptional, and I think that and we've been
Yeah,
looking at some
the
data
one
on
thing about
robot density,
right
and the
with robotics.
density of robots to number of employees at Amazon is just beyond anything in automotive or general manufacturing, and certainly more than the consumer market. And that's we have a few lawnmowers and vacuum cleaners in our homes these days, but the level is by comparison is so vast at Amazon. So what have you learned about that process of scaling there?
Yeah, so well, when you're applying robotics to individual customers, right? It's you want to have breadth, and you're willing to go up a little bit of depth in order to make sure that you can supply as much benefit as you possibly can to your customer base. When you end up being an encaptured solution like inside of an Amazon, you need an unbelievable depth and reliability, right? So I would actually give up functionality for reliability. For Amazon, 99.9% reliability means that hundreds of thousands of packages are not making it to the customer, which is absolutely unacceptable, right? So I've had the lucky for me, really, ability to be able to see now both sides of the house. How do you create a solution that is as broad as possible? How do you create a solution that is deep as possible? And then actually, can you get to that perfect Venn diagram between those two, where you can say, look, I'm going to give you 4, 5, 9 reliability, but allow you to have some flexibility on the side so that you can adapt to the way you're doing it. Amazon does have, we sell everything. We're the everything store. We were when I was there. And so having to be able to manage hundreds of millions of different types of products does bring its own sort of interesting problem. So a lot of the technology is actually almost more philosophical of how do you attack robotics and automation in a way that provides solutions that are both reliable and flexible, more than I really have to worry about how this particular motor works or how that particular technology works. I want to bring that more back inside to us.
So what are some of the things that you've learned in achieving that?
That simplicity.
How do you do it?
Yeah, right. Um, one of my philosophies that I've kind of picked up over the years is that complex is easy, simple is hard. And by that I mean, if you make a solution that is as broad as possible, that is super complex and has a lot of moving tech parts on it, that's not very reliable. That's very easy actually for us, for as engineers and as people who develop robotics. It's easy for us to do, but it makes it very hard for the customer, right? Because operations has to continually update to whatever manifestations. You have to adapt your processes to whatever technology we have. Making it very simple for the user is very hard for us, right? And you have to really think about what's the best way I can do this to make this as easy to deploy for the customer, to have as limited interaction, to make the technology kind of push into the background so that you can worry about your processes and what you really want the business to be able to do. And so that's really a fundamental thing that I've learned from my years at Amazon and from my Kiva days is it's up to us, the technology people, to take on the complexity internally and make it as simple as possible for the customers. And you can see examples across robotics of that, of both sides of that house.
What have you, I don't know, are you able to maybe elaborate on some of the things you're seeing people do? In terms of what are some of the behaviors you would argue that are the antithesis of the simplicity? What are people doing when they're designing systems that are overly complex, that are, and through that creating fragile, inflexible systems? What are the key mistakes people are making today that you would argue are the things to watch out for?
Sure. I'll give you two. I'll give you two sides of the house. So on one side of the house, I would say in our world that with mobile robotics, that both of you and I deal with quite a bit. There's concept of there's AMRs, which autonomous mobile robots that can kind of move anywhere they want to, and then there's AGVs, which are autonomous guided vehicles. The concept of an AGV is an excellent example of, I as an engineer find it very difficult for me to figure out a way to move into a complex environment. So I'm going to put upon you, the customer, that you have to lay down tape and you have to lay down paths and you have to change your entire environment so that my robot can go travel very easily through your system, right? That is a classic example of how engineering somehow thinks that if I can make I can provide some benefit to the customer by making them actually make an inflexible, unchangeable, complex environment that they have to maintain, but then my robots will work great in them, right? Well, that's just not fair to the customer, right? We shouldn't be able to do that. You should be able to say, hey, I have a robot here. I want it to move over there. You go figure it out. Not, I'm going to tell you exactly what path it is, maintain that path, and that path changes, and I have to change my building. I have to go change that. That's just not fair, right? So the very concept of AGVs to me is an example of this. On the other side of the house, a lot of our robotics have recently in the news has been moving towards, humanoid robots, right? Which are unbelievably complex, but extremely fragile, right? They just are very difficult to get to work. And they provide a very generalized solution that doesn't necessarily solve a specific problem, right? So, for example, agility these days is using a humanoid robot to move a tote. There are a lot of easy ways to move totes. You did.
Yes, I've often thought that when you see the video of it doing that, moving 6 foot, a box 6 foot, you think, well, yeah,
Right.
why?
So, and even as human beings ourselves, if you think about it as a human being, when we go do a job, we end up becoming very adept at a particular task, right? So humans actually simplify their world to be adept at a specific thing, right? So creating a completely complicated, extremely generalized solution and then hoisting it onto the customer and saying, all right, you go figure out how you want to take this generalized technology and make it into a specific task is also unfair, I think, right? Because then you have to take on all the complexity of all the other things this robot can do that aren't necessarily relevant to you. So I think on both sides of the house there's making me change my environment, making me change the way that I do things in order for the robot to work, or making me take a technology and figuring out how to reapply that technology so that it works inside of my environment. You lose flexibility on one side or you lose reliability on the other side. But either way, it's not fair to the customer. We should be taking on that technology problem. We should know which problem we're trying to solve, and we should go in and try to solve it.
It's very interesting. So we often look at it as that AGVs are essentially quite simple machines in cost, but require a lot of cost in terms of infrastructure and setup.
Mhm.
Whereas an AMR has eliminated the infrastructure cost of the environment, allowing you more flexibility, but has moved that complexity and cost into the machines. You might see some with three 3D LiDARs, three Intel real sensors, God knows, a lot of compute and so on. So the cost has shifted, and they're still also quite brittle in the way they operate. There's a lot of situations where they fail, like scene change, lighting, featureless and aliased environments and reflections and so on. So they're still both quite struggling. They've moved the problem around, but they haven't eliminated it.
Correct.
And so for us, the thing we often talk about, we don't talk about it very openly, but we often refer to them as naturally autonomous robots inside Opteran, which is where you've eliminated the infrastructure complexity of, but you've also eliminated all of the cost and complexity of the system and the sensors and the hardware that go with it. And that's kind of like what you're saying, really, isn't it? This is your notion of simplicity, a system that is so simple it can just operate without either of those constraints of AMRs and AGVs.
Right. In fact, I'm starting a company just because of that. Right. So that's really the fundamental concept behind this startup that I've been working on for 3 weeks now. Is the other aspect of what you're saying, because I agree 100% with what you're saying, is that it creates a pretty high barrier of entry for customers. Right. I think every single person who does distribution or manufacturing or even retail restocking would love to have a robot that can kind of do the walking for them. Right. But the barrier of entry is extremely high because of one of the two things you're talking about. Either with an AGV, I have to change my whole infrastructure so that I can have an AGV in there, or I have an AMR and I'm going to have to spend tens and tens or hundreds of thousands of dollars in order to get a robot in there. And if it doesn't work, I'm just out of that money, right? So it's very difficult for me to figure out a way to have a very flexible robot that I can hopefully adapt to my environment, and I can see whether or not I can actually get this thing to work. And I think that's a huge hole in the marketplace that I'm hoping that I can figure out a way to get into and say, look, I want to create a very lower cost, high reliability, flexible robot that will be able to go in and adapt the way you want to do your business, not have you adapt your business the way that we want to create our robot. And that's one of the reasons, obviously, I got very interested in Opteran, because I think philosophically you're in exactly the same spot with the Opteran brain.
Yeah, that's okay. That's a good, lovely segue. I like that. So obviously, that's what the reason we're doing this recording is to talk about what we're doing and the experiences you're having. But for us as a company starting on that journey with companies like yourself and others to introduce our software into the space, what is it that we're doing that you think is of such interest? Why do you bother? Why we chat, right? And we talked a lot, you and I. But why do you talk to us? What is it that we're doing that really resonates with you? Why do you care? I mean, you can talk to a lot of people, right? There's a lot of, but there's something about what we're doing, and obviously it's important for us to communicate that. But hearing you say that would be. And I should hasten that I haven't prepped you on this. I have no idea what that's going to sound like. We might have to cut it. But I'd love to hear your thoughts on how you think about what we do with our Opteran Mind and that software product that we've built.
Right. And again, I'll give you a couple of answers. One is, so David, you're nice enough to send me a sample product. I was able to get an Opteran brain up and running in my house, and in fact in this room right here, in under an hour. Right. So that's exactly what I'm talking about. Right. That if I called up another sensor system and said, hey, I want to create an autonomous AMR robot and have it run in my house, it would be like, all right, we'll hire 5 developers and I'll see you in 3 weeks, right? And instead, really in an hour, I've got something up and running around inside of my house. So that may seem like, obviously it's very simple. You turn on the robot and it works. That kind of simplicity to me, the customer, means that there is an incredible amount of work put on by Opteran to make that simple for me. You've taken all the complexity onto yourself. So that's really one general aspect of it. The second is that, we've been in this industry now for 15, 20 years, right? I've been in this industry for 20 years. AMRs have been around for a very long time, right? We should be able to say, look, the autonomous mobility aspect of AMRs has been solved, right? We figured it out. We should be able to go out there and say, hey, look, you as a robotics startup person, that would be me in this case, say, hey, look, don't worry about the autonomous mobility part, and obviously I don't have to build my own motors. Those are all done for me already. I don't have to build my own casters. Those are all done for me, right? Some of the components are already built in. That infrastructure should be there. You can go focus on the customer's problems. So that's the reason I'm very interested in continuing this relationship with you and Opteran, is that I can now focus on what I think is important in the industry and allow you to focus on providing technical components that just work, that are very simple, and really philosophically work exactly with the way that I want to approach my company and how I want to solve problems for my customers.
I mean, for us, that's, early days is really about localization and mapping. And, we'll be bringing out collision avoidance, which we've got working in the lab. And ultimately, we have even natural brain decision making working in our early research team. And this is all about really simplifying that. I mean, an hour to set up is even too long. It should be minutes, and you should be able to do it so that the environment can change and it can be dynamic, because nowhere's static, is it? I mean, I think these are some of the challenges that people really are facing. I mean, I think that's probably worth us spending a moment on. Some of the things you've seen in application in Amazon, some of those sort of usability challenges are like light, dynamic environments. There seems to be so many things that cause systems to break that we need to get our head around.
Mm-hmm. Yeah, so people think that a fulfillment center or a warehouse in general is a relatively static kind of a location where I say, all right, I can do fulfillment over here, I can do receiving by the docks, I'm going to do, pack out over here, and then I put it in the truck over there, and the building we set up the building and then it runs. It's not like that at all, right? It dynamically changes daily, weekly, right? And for those of you who don't work in warehouses all time long, you can think of it as even through the year, right? If you think about, at Halloween, I've got all my Halloween stuff, and all of a sudden all my Halloween stuff goes away. Well, in a physical manifestation of that means that you're actually changing the way that your building looks, right? And then, of course, during the holidays, I have an massive increase in spike in volume, which then decreases down. I have to change physically the way that the building actually works, right? So to say that I'm going to expect a static environment and have my autonomous robots work inside of that static environment is ludicrous, right? On its face value. So having an ability to have a vision system and a way for me to be able to move my robots around that can adapt to that kind of changing environment is very critical to me, right? I don't, again, go back to the HEVs. I'm not going to have a single path I'm always going to follow down. I want to be able to say that I can go down there and understand that, okay, now this is now a pallet storage area because we ran out of space. Adapt your way, move your way around that pallet storage area without me having to go and explain to the robot, oh, by the way, there's going to be obstructions here for these 3 weeks because we suddenly got in 55 pallets of diapers and we don't know what to do with them all, right? That's not what the person who's running the building should worry about talking to the robot about. The robot should adapt to that kind of environmental change. Additionally, if you're a worldwide company like Amazon, you have buildings in Texas that are, it's 120 degrees out. You've got buildings up in Maine where it's 10 below zero in the winter. And you have, as you said before, huge lighting concerns, right? It gets very bright, it gets very dark, it gets very hot, it gets very cold. Your environment changes a lot depending on where you are worldwide, and you actually even move different types of products where you are worldwide. So you have different infrastructure. In Japan, it's very hard to you don't have a lot of space, so you have very tight, constrained buildings, whereas in Pennsylvania, I can actually have very large buildings with wider aisleways. So having a system that can actually adapt to those different types of environments, even when I'm trying to do solve the same problem in different locations, it's going to change through where I am and even through the year, right? And again, lighting changes dramatically through the years depending on where I am. And again, I'm as a person of operations running a building, I don't want to worry about that, right? I don't want the robot. The robot, you take care of that, right? I've got other things. I'm going to put stuff in boxes and put it in trucks and get it to people's doors.
Something I'd be very curious on, sort of trying to shift the gear maybe a bit to the future. I mean, you've touched on things like form factor. Obviously, humanoid robots at the moment are all the rage, and they are quite incredible machines that we've engineered. And we see that, I think that raises questions about form factor, which you've touched on a little bit. But also, a lot of what we see today is very LiDAR and data intensive. A lot of the, as you say, that a lot of the systems like Agility and others kind of can move a tote across a small aisle, but other things could do that. But to do that, they've had to scan and train on large volumes of data. There's a lot of use. Whenever you look at these systems, there's always some sort of puck LiDAR often, or half a dozen Intel real sensors plugged into them. I'm exaggerating slightly for effect, but there's a lot of sensor and compute, a lot of networking required, a lot of data and processing to train these systems. Do you, if you were to cast your mind forwards and think about how the future looked, whether it's the types of sensors or the form factor, what does robotics look like to you? Yeah, it could be whatever it is. I'm just giving you some examples to frame the thinking, really. But how do you imagine, I don't know, 10, 20 years, maybe even further down the road, how might the systems we're building look? What kind of technologies might we be using? And do you really think that people are going to be doing all this data processing going forwards? Well, we don't, but we think that's a dead approach. But that's kind of leading the audience. But they do. I'm curious to just that sense of how does the future look for you?
Yeah. So when I got into this industry 20 years ago, right, the idea of applying robots to fulfillment was insane, right? No one ever thought about doing that, right? And there was a psychological hurdle for people to get over to say, hey, look, you can actually have robots working in an environment, interacting with people, and being there. And I know I want to get to a technology aspect to your answer first, but there is a psychological aspect to this answer, which is, are people comfortable enough with the concept of a robot working beside them before you can actually deploy and apply those, regardless of the technology? So for humanoid robots, I don't think we're there at all. Right? I don't think that we've gotten to a point where people would expect a humanoid robot to be wandering next to them, right? Even when I had humanoid robots in my lab that I was working with in Amazon, it was still, anytime we fired up the humanoid robot, everyone stopped, turned, and looked to say, what the hell is this thing, right? Because you're just not used to it yet. So I think philosophically and just from a psychological standpoint, in the shorter term, I think the next generation of robots may use some of these larger language models to learn, but I think it's more of a technology is getting us comfortable with the fact that there's going to be robots surrounding us constantly, right? We're going to have collaborative robots that are working with us constantly, doing very simple tasks like this. And I still think we can use some of the AI large language model kind of philosophy in ways that we were talking about earlier today, which is, again, I put 40 pallets in the way. I've known that I've gone down, me as the robot, I've gone down this path 50 times. There's never been anything in the way. Oh, now I see that there's actually something in the way. I'm going to tell the next robot so that they know that there's actually something in the way, right? That is generative AI of collaborating between the robots so that they can actually learn and have the system actually adapt to the way that things are changing in their environment around them. A relatively simple way of doing it, but I think it's rather important that the technology has moved forward to the point where I can expect, as the president of a robot company, that I'm going to have that ability to have that artificial intelligence in the background so that I can help solve other customer problems. So I think we have one more generation of robotics in front of us over the next 10 to 15 years of just when you walk into a building, a decade from now, you'd be surprised if there aren't 20 or 30 robots running around inside the building, right? That would be, rather than now, when you walk into a building, you would just say, wow, look at all these robots. This place is really cool. Now it would be, this place has no robots. What the hell's wrong with them, right? So I think that's where we are.
Or even people just won't notice. It's like the electric light bulb 100 and something years ago. It would have been revolutionary to be able to turn the night into day. Whereas now we literally buy them for $1 or something from a corner shop, and we don't even think about it. It's a throwaway, ubiquitous item we pay no attention to.
Right, and then I think 15 to 20 years from now, then you'll start seeing the humanoid robots that people are putting a lot of money in today. I think that promise is one generation away before they actually will be able to do that. So why do I think that the next 15 years is going to see a large proliferation of robots out there? It's because of some of the foundational technology has really advanced a lot, right? There's, as the Opteran brand is an excellent example of that. I've taken the ability to go and do mobility inside of a complex environment and it's solved. There's ways that we can actually solve that problem that are relatively low cost, have a low barrier of entry, and still allow solving problems for the customers. There's, manipulation has increased dramatically over the years. So there's a lot of different technology out there for me able to go in and use end effectors to be able to understand things and being able to understand a scene, a complex scene, and being able to manipulate products. Gantries are much more reliable and flexible now, and the costs are coming down on those as well. And I think there actually is a very interesting inflection point that we've hit as a society in that 10 or 15 years ago, if I wanted to go hire someone who had a robotics degree, there's nobody out there, right? There's maybe one or two universities that had robotics degrees. Now, there's thousands and thousands, tens of thousands of people coming out of universities worldwide that have robotics degrees, who understand robotics and have been studying robotics now for, quite a bit of time. And there's a lot of academia internally where people are actually creating projects inside of universities for robots, such as Opteran. So that suddenly we have this influx of talent that's coming into the industry. We have an influx of existing technology that's now available in the industry. We can drop the cost down, we can make it more prolific, and we can make people more comfortable with it. And it should be a natural environment for everyone to be able to work in around robots. And I think that's really the revolution that's going to happen over the next 10 to 15 years, more than we're going to have a robot army of people wandering around inside of our buildings. I think, again, that's one generation.
I think I saw an analyst report talking about that there's no chat GPT moment for robotics. It's going to be, there's lots of points coming together that enable a gradual on-ramp to a world in which they're just everywhere. But there's no sudden aha moment where we're going to see, like you say, suddenly thousands of humanoid robots walking down the street anytime. Anytime in even close to any kind of realm of the future that we can kind of imagine at the moment. It's interesting. So tell us a bit about your business. I mean, we haven't caught up on it for a little while. I know what you're doing, but I'd love you to just elaborate a little bit on what exactly is. Do you have a name yet?
Yes.
Have you?
We do have a name, and we are incorporating next week, I think. So it's 53 Robotics, very simple name. So the initial robot that I want to create, the initial problem I want to try to solve inside of distribution, obviously I've been in distribution for 20 years, is what is often called ad hoc or non-value added workers, right? So about 20% of the people who work in a fulfillment center are actually doing supporting type of technology, supporting type of labors and processes. Moving a tote from point A to point B, they're refilling your boxes, they're picking up all your IT equipment, they're doing a lot of walking around inside the building to maintain the level of processes necessary for you to do actually what you really want to do, which is put orders in boxes or transport things to get out to where you want to go. And people really have not tried to automate non-value added or ad hoc labor very much because by definition it's flexible, it changes all the time. The technology, the items that you're moving behind you are always different, right? It's a hard thing to automate because there's no basis for you to do the automation on it. What you really want is a very low cost, flexible robot that can go and adapt and change the way you want to do things and say, hey, look, I need to bring this new barcode scanner and take it here and bring it over to station A, go do that, right? That's the way I want to interact with my robot. That's the kind of robot I want to bring to the marketplace where people can actually just say, I want this robot, hey, you do this, bring it over there and do that, and it does it for you. And you don't have to worry about anything in the background. I'll keep the cost low and I'll keep the technology high so that it makes it very simple for you to deploy in order to be able to do that. And that's the hole in the marketplace that I'm really trying to focus on right now.
That's 53. And why 53 robotics? Is there anything?
I like the number.
You just like the sound of it? You like the number. I love it. You'd have to come up with a backstory that's as to why that means something, I think.
I could change the backstory as the company evolves. So it's a nice going for.
All right. Well, listen. Obviously we're behind you at 53 Robotics. You've got one of our machines. Very happy for you to have that and play with it. I hope you have some good fun with it. It's been nice talking to you. I'm not sure we could probably keep going, and we should probably do it over the next time we have a beer. But it's been lovely having you just chat to us, Greg. It's nice to just kick some of these thoughts around. I mean, do you have anything you want to share before we close off, or?
No, I want to thank you guys for all your support that you've provided me, and again, I would not have gone on this journey of starting my own company if there wasn't technology like Opteran available to me in the background. So I want to thank you for giving me the ability to go and try to start my own company and try to see if I can solve a new customer problem and bring something new to the marketplace. So thank you guys for that.
Oh, well, a pleasure. We're looking forward to see what happens. But listen, thanks a lot. We wish you every success, and let us know if you can help out in any way. We'd be happy to help.
Okay, hope to see you soon, Dave.
Thanks for your time.